In section 3.5, we're working with double angles. And so we have these formulas. We have three different ones for cosine, where we're taking 2 times the angle. And then we have for tangent. Here's our formula. And we also have some double angle formulas that we'll be able to substitute in for sine squared or cosine squared or tangent squared. We also have our half angle formulas. So here for sine, cosine, and tangent we have plus or minus the square root of these values. Now in determining whether or not it's going to be positive or negative, that comes from the quadrant that our angle theta over 2 is in. So that is determined by our quadrant of the angle so that's what's going to determine if those are positive or negative, is what quadrant we land in. For tangent, we also have a couple here that do not have the radical, and we have some half angle formulas here for sine squared, cosine squared, and tangent squared. For this example, we have the sine of theta is equal to 4 over 5. We're in quadrant 2. And we're going to find the exact values of these different, here we have the sine of 2 times theta and cosine of 2 times theta, so a couple of our double angle formulas. And then we have sine of theta over 2 and tangent of theta over 2, a couple of our half angle formulas. Alright, and the first thing we're going to want to do here is let's draw ourselves a triangle. We're in quadrant 2. So here's our theta. And we're told that sine is 4 over 5. That's opposite over hypotenuse. That makes our adjacent side 3. And because we're in quadrant 2, that would be a negative 3. So now when we look at the sine of 2 times theta, we know our formula for that is 2 times the sine of theta times the cosine of theta. So if we look at these values here, that's going to be 2 times the sine, which is 4/5, times the cosine, which is negative 3/5. Now we multiply across, and our exact answer is negative 24 over 25. If we're looking at the cosine of 2 times theta, so let's use our formula 2 times the cosine squared of theta minus 1. Again, we just determined that the cosine is negative 3/5, so now we're going to square that. Now we're taking it times 2 and minus 1, so 3/5 times negative 3/5 times negative 3/5, that's going to give us 9/5. 9/25. So that would be 18 over 25 minus 1, which we could write as 25 over 25, which is going to give us a negative 7/25. And that would be our exact value. Now it's sine, and we're looking at a half angle here. So let's see, we have plus or minus the square root of 1 minus the cosine of theta all over 2. So the cosine of theta, again, negative 3/5. So we're going to have 1 minus, so I'm going to write that as 5 over 5, minus our negative 3/5, so plus 3/5. And that's all over 2. Taking the square root of that, and our half angle would fall into quadrant 1, and so this is going to be positive. And so now we're taking 8/5 all over 2, square root of all of that. So again, dividing by a fraction is the same as multiplying by the reciprocal. So we have 8/5 times 1/2 So we're taking the square root of 8 over 10, or 4/5, which is going to give us 2 over the square root of 5, which is 2 square root 5 over 5. That would be our exact answer. And for our tangent, let's use sine of theta over 1 plus cosine of theta. So now our sine of theta is 4 over 5. And then cosine is still negative 3/5. So I'm going to rewrite this one as 5/5. And we are adding that. So 5/5 plus a negative 3/5 is going to be 2/5. Still 4/5 for our numerator. Going to rewrite this 4/5 times the reciprocal, so 5 over 2, and those cancel. 2 goes into 4 twice. That would be our exact answer.